Okay, this series of videos is going to give you the basics about quadratic functions. We've already sort of investigated them a little bit because I've tried to give you guys an idea of some things so that when you saw your practice STAR test, you had, some ability to maybe do a little bit of it. But we're going to stop and kind of go through these modules a little bit at a time to give you a more thorough understanding and give you the tools that you need in order to answer questions involving quadratic equations. So I am actually in Module 16 on page 771, and we're going to start with just simple information about quadratic functions, okay? A function that can be represented in the form of f of x is equal to ax squared plus bx plus c is called a quadratic function. Okay? The terms a, b, and c are constants, and a is not equal to 0. The greatest exponent of the variable x is 2. The most basic quadratic function is just f of x is equal to x squared, which is the parent quadratic function. Okay, so all of that sounds really fancy. But basically, all they're saying is your most basic quadratic function is just x squared plus 0x plus 0, if you want to, include this other part, okay? This is your parent function, your basic quadratic function, okay? All quadratic functions will follow this format, and this particular format of a quadratic function is called standard form. We will also run across something called vertex form. Similar to what we had when we did linear equations, we had 3 different ways to write a linear equation. We could write a linear equation in standard form, we could write it in point-slope form, or we could write it in slope-intercept form. So similar to that, quadratic functions, you can write them in standard form, which looks like this, or you could write it in what's called vertex form, which we'll get to. Okay? All right. Very quickly, I am going to plot your basic f of x is equal to x squared. And then we're going to talk about these different pieces of vocabulary. All right, so you see that I have filled in the table with x and y values using this equation for my quadratic function. Remember, that is your simplest quadratic function. It's called your parent quadratic function. So this is what your parent quadratic function looks like. Okay, the type of shape, the curve that a quadratic function creates is called a parabola. Okay, the point through which the parabola turns direction, the point that it turns around, like here, for instance, is called its vertex. For the parent function, the vertex is 0, 0. Okay, a vertical line that passes through the vertex and divides the parabola into 2 symmetrical halves is called the axis of symmetry. For this function, the axis of symmetry is the y-axis, or in other words, the axis of symmetry is x equals 0. Okay? Okay, so I've labeled a few things. The vertex, the point that it turns around at, that's, for this particular, for the parent function, your vertex is 0, 0. For the axis of symmetry for your parent function, it's the vertical line x equals 0, in other words, the y-axis. Also, we haven't talked about it yet, but just based on looking at this parabola that is created by this parent function, we're going to eventually start talking about zeros and the solution to your quadratic function, and those are where your quadratic function crosses that x-axis. In other words, where is y equal to 0? In this particular case, for the parent function, there is only one solution because there's only one place that this parabola hits the x-axis, and it's at the vertex. Okay, what exactly those are going to be, where's the vertex, where's the axis of symmetry, what are the solutions or zeros, those are going to depend on the format of the quadratic equation that you're given. So like I said, all of your quadratic equations will have, there will be a vertex when you draw the graph. There will be an axis of symmetry. There could be one solution or zero, two solutions or two zeros, or there could be even no solutions, just depending. But those are characteristics that all of your quadratic functions are going to have. I'm now on page 772, and we're starting to look at some variations with our quadratic functions. So I've gone ahead and shaded my parent function green. So the original function, f of x is equal to x squared, is in green. Well, what if that what if it's not just x squared? What if it's maybe 2x squared? Okay. What would you get then? Well, if a is greater than 1, the absolute value is greater than 1, then the resulting function is basically going to be taller and skinnier than your parent function, okay? And that is called a vertical stretch. So when a, or the absolute value of a, is greater than 1, it's called a stretch, and you're going to wind up having a skinny function. When a is basically a decimal or a fraction, meaning that it's between 0 and 1, like maybe it's 0.5 or something like that, then you're going to notice that the new function is squattier and fatter than your parent function, okay? Okay, so when I went ahead and paused, and I went ahead and shaded our parent function over here as well. So bottom line is parent function is just f of x is equal to 1x squared, basically, okay? But what if the number in front of x squared is greater than 1? Well, then it becomes kind of a function, a parabola that's stretched. It's tall and skinny. What if the number in front of x squared is a fraction, maybe like a half, 1/2 x squared? Then it's going to be squished and fatter, okay, and that's called a vertical compression. Sometimes you might even hear a vertical shrink. It's squished, okay? All right. Next little bit that you need to understand is down here. The domain of a quadratic function is all real numbers. When a is greater than 0, the graph of g of x opens up, okay? Basically, when a is positive, the graph's going to open up. And if a is negative, in a minute, we're going to find out the graph is going to open down, okay? So the function is either going to have a minimum value, like this is the smallest value for this, both of these functions. This is the smallest value for this function, okay? Because everything else is above the x-axis, okay? So that's a minimum value. If it was turned downward, then we would have a maximum value, and I'm sure that we will have examples of that in just a second. All right, so just a reminder, basically in so many words, they said if a is positive, then the parabola is going to look like more like a U, and it's going to have a minimum value. If a is negative, then it's going to be oriented the opposite direction. The arrows are going to go down, and you would have a maximum value, okay? All right, looking at this example, again, we're starting with the parent function. I've put it in green, just like I have been. That's just f of x is equal to x squared. Okay, well, what if instead of a being a positive 1, like here, what if a was negative 1, negative x squared? Well, then you'd have this blue one. It's basically a reflection of your parent function, okay? Because it's negative x squared. All right, well, what if you took this vertical stretch, which you had a couple of pages ago, and it's still a vertical stretch, but this time the value of a was negative instead of positive? Okay, well, it would still be a vertical stretch, but because a was negative, it would point down rather than up. Okay, so something like this, negative 2x squared. So the absolute value of a is greater than 1, which means it's going to be a stretch. But a is actually negative, which means it's going to point down rather than up. Okay, it's both a reflection of the parent function and a stretch, so it's both. Okay. All right, we're going to come over here and look at what happens when we go from our parent function to reflecting our parent function, but then compressing what we get after we reflect it. Okay, so again, we go from parent function to a reflection. Basically, it goes from x squared to negative x squared. And then if the value of a is a fractional value, then it's going to be fatter, squished, whatever. It's a vertical compression. And it's turned this way because the value was negative. So if the value of a is negative, that's basically a reflection, and it's going to open down rather than up. If it's a fraction, that means it's going to be a compression. If a is greater than 1, it's going to be a stretch. Okay, so you're starting to look at varieties of quadratic functions and how they can kind of differ. We start with the simplest variety, which is f of x is equal to x squared, and then we start throwing in some variations.